Before you start your test on your aircraft, you want to make sure that your Pitot Static Tester will be able to perform all the checks without any problem. In order to do so, you will run the self-test. To run the self-test, there are one very important thing that needs to be done. We need to leave both ports for each pitot and static open to ambient. That is very important because if we run the self-test while we are connected to the aircraft, damage might be incurred on the aircraft and the instruments. When you made sure with a visual check that both ports are open to ambient, you may start the self-test by pushing the test button right here. It tells you open both output ports to ambient, then press go. Press cancel to exit. Now we can press go. The self-test will run some checks to make sure that the test set is fit to be used on an aircraft. I recommend doing the self-test once in the morning when you're taking the test set out of the tool crib. If you have multiple checks to perform that day, you do not have to repeat the self-test every single time. One thing I advise is usually if you have the tester come out of sight for more than a certain period of time, it is advisable to rerun the self-test. At the end of the self-test, the tester will show self-test successful. You can press cancel to exit. At this point, you'll be able to connect your tester to the aircraft. For my training, I will just cap off the ports, but at that point, you would be connecting the host kit assembly or your air data accessory kit to the test set and get it ready for the test. At the same time, now would be a good time to go in your aircraft, set the baro at 2992 or 1013.25 millibar, and pull all of the breakers for the pitot heat, for example. Now we're going to pair the iPad with the tester and continue the training from that iPad. You will first need to go to the App Store and download the Laversab app called 2-CH, which stands for 2 channel. And from there, you will be able to launch the app once you're connected to the test set. After you downloaded the app from the App Store, you will go in Settings, go in Wi-Fi, and select the test set that has the same serial number as the test set you are using. Here you will see a Wi-Fi network showing up, showing LAV-86471, and I will make a check here to make sure that the serial number is matching. This is to ensure that you're connecting to the right test set if multiple checks are going on in the same hangar with different boxes. When I click on the network, I will be asked for a password. The password is LAVUS and then 505. To confirm, I click on join. Now I go back to the main menu and I will launch the 2-channel Laversab app. Make sure not to download the 3-channel app, which is only made for the Model 6600 NG, specially built for smart probe aircraft. As you can see, the interface between the wired remote and the Wi-Fi remote is very similar, which means if you've been trained on one unit, you've been trained on the other. In order to start the iPad, I will now push the power button for a couple of seconds, and all of the data will be populated right from the wired remote. Et voilà. Couple of notes on the iPad. Once your iPad is connected to the tester, the wired remote will show wireless remote enabled, keypad locked, which means you cannot do anything on the wired keypad once your wireless device is on. And that is because we do not want to have multiple interfaces being able to operate the same test set. Additionally, once you have connected one wireless device, you will not be able to connect another wireless device. And whenever you try to connect here in the settings, in Wi-Fi, another device to that network, you will get an error message. Finally, if by any chance your iPad should lose power or malfunction, your wired remote will automatically regain control after a timeout of about 30 seconds. Okay, now we are ready to start the unit and get going. In order to switch the tester from measure mode into control mode, which will allow us to generate pressures, airspeed, and altitude, we have two different solutions. One, I do not really recommend, but I will still mention it. The other one would be the right way to go. The first one is push one of the ovals and select control here. By selecting control, both channel pitot and static will be switched to control. And as soon as you click on go, both channels will be confirmed and go into control. The reason why I do not like that solution very much is because whatever value is in the target boxes here for pitot and static will be executed. If you do not pay attention to what those values are, you may go to an altitude or an airspeed that is beyond what the aircraft can take. The right way of starting the unit and put it into control is much more simple than that. It's the ground button right here. The ground button, when pushed, will do the same thing. It will switch both of your pitot and static channels into control, but it will also confirm a minimum airspeed of 20 knots and the current atmospheric pressure of minus 225 feet for static. That is much more convenient because you are guaranteed to get always the same value, a safe value at ground, which is 20 knots, and your current atmospheric pressure, currently minus 225. For those who have been using the older 6300 Legacy, this is much more convenient now. You do not have to leave the ports open and type function 7 to set your ground, then close your ports or connect to your aircraft and then press function 8. This will take care of it for you. When I'm ready to confirm, I can click on go. A little bit of explanation about the blinking here. On every Laversab tester, older generation or new generation, there is a double validation process that has two purposes. The first one is ensure that whatever you've input was the correct thing and was what you wanted to do. In this case, I'm going to ground and this is what I want to do, so this is good. The other function is to allow you to input more parameters if you want to. We will see that later on when we do the leak check, but this will come very handy when we need to input airspeed and altitude and have them both sent at the same time. Some AMM requires that. For now, I'm just going to click on go and the tester will switch to control, the pumps will turn on and the box will control at ground. Let's go. Now you can see 4 letters, it's EQZN and stands for equalization. This is just a mode in which the tester comes in for a few seconds that will allow to send a smooth pressure for PT and PS so you don't get a spike of pressure when the electrovalves are finally open and pressure is sent to your aircraft. This is to ensure a smooth transition of pressure. Now you can see the test set is stabilizing at the target values that we've entered, 20 knots and 225. From there, it's very intuitive and easy. The next step for our typical use is going to perform a low-level leak check. So let us do that. Low-level leak check is something that we recommend, even though it's not mandatory. Always follow your work cards if necessary. The low-level leak check will allow you to figure out if you have a leak at a low airspeed or a low altitude, so you don't have to go all the way up to the usually high altitudes and airspeed that the AMM requires you to go to. And will save you a lot of time if your leak is higher than more than the aircraft maintenance manual limits are. In order to change my airspeed, I have now 3 choices. I can either, just like the wired remote, use the button number 2 here to change my target airspeed. I can also push number 2 here now that I have a touchscreen device. Or I can simply push the blue box and that will pop the same menu. For each of the 8 different input parameters, you will have the same possibility. Let's start with the first one. My low-level leak check asks me to go to 100 knots and leak check at that value. So let's do that. I'm going to push on the blue box here and input 100 knots. I'm going to click enter. I will make sure that my rate is compatible with the aircraft that I'm testing. Currently 500 knots per minute is on the higher end. So I'm going to change that by pushing on the rate blue box and change it to 300 knots. And click enter. That's all I want to do for now. I want to leave my static at ground and send my airspeed to 100 knots at a rate of 300 knots per minute. Let's do that. Whenever I get there, it's good to let the tester stabilize for a few seconds. Usually, I leave it 10-15 seconds at the target airspeed or altitude. So now I've reached my target airspeed of 100 knots, and I'm going to wait for another 5 seconds for the pressure to stabilize. At this time, we're going to start doing a leak check. To run a leak check, you have 3 possibilities to input that. As for the airspeed, the first one would be to push number 4 here and select leak. The second one would be to push 4 on the numerical keypad and select leak. And of course, the third way, and the easiest to me, would be to just push the oval button and select leak here. And now we will start a leak check on the pitot side. Note that the static size remains in control. If you'd like, you can leak check both channels at the same time, but hopefully you are lucky, because if you have a leak, you will never be sure which channel it is coming from, since pitot is the addition of static and pitot. Now I'm going to leak check and click go. When I start the leak check, a new menu pops up. It's the leak check menu. It will give me leak time, which is the total time during which the leak check has been going on, currently 14 seconds. It will give me the start pressure, 100.1 knots, and it will give me information about the leak timers that I can change later on, and we will see that in the functions. Currently, the leak timer is set at 1 minute, 5 minutes, and 10 minutes. So let's simulate a leak here. I've opened the valve here to simulate a leak for us. Note that you have now your instant leak rate here, which means you can work on your leak directly while the leak check is going on. As I fix my leak, you will see that I close my pitot crossbead right now, and you will see the leak decrease until it completely disappears. It's very useful and will save you a lot of time when you're doing leak checks like that. I still have my total pressure remaining here. After 1 minute, I get the results of my leak check. This is what is left in my channel, 97.1 knots. I've leaked a total of 2.9 knots, and I've leaked an average of 2.9 knots per minute, which is the same because the leak timer was set at 1 minute. Okay, I can consider that my leak is pretty good, so I'm going to cancel. Whenever I cancel, the tester will come back to the previous target, which was 100 knots, and stay stable there. Now, let's do static. On the static side, the low-level leak check procedure asks me to go 3,000 feet above current ground. This is an approximate value, and you don't have to go exactly at 3,000 feet, but you can do a quick math and figure out that we're going to go now at 2,800 feet to simulate that 3,000 feet above ground. Always, again, make sure that your rate of climb is fitting with your aircraft. For me, 5,000 feet is good enough, so I'm going to generate 2,800 feet now. To do that, I can click on 6 here, click on 6 here, or, as usual, select the blue box and select 2,800 feet, click enter, and since I do not need to change my rate, I'm just going to click on go. As you can see, it is very easy and intuitive to generate airspeeds, altitude, change rate of climbs, or change rates of acceleration on this tester. We're now reaching the level of 2,800 feet. I'm gonna wait for it about 10 seconds for it to stabilize. And now we're going to start the leak check. I'm gonna push on the oval here. Select leak. And again, I got my leak button here starting, and my pitot channel stays in control. Now that I'm ready, I'm gonna click on go, and the same leak menu will show up with the same leak times and the 3 same leak timers with the starting pressure here and the current leak on this test set. And I'm going to open the static vent a little bit to simulate a larger leak. This is the kind of leak that you would get. After 1 minute, you get the result here, 106 feet per minute, a total of 106 feet, and this is what is left in the channel right now. The tolerance for the low-level leak check is 1,000 feet for static and about 20 knots for pitot after 1 minute leak. In our case, we are perfectly fine, so I'm going to cancel out, and the test set will come back to control. I'm going to close the static vent here. The test set will come back to control, and we'll stay there. All right, that was my low-level leak check right there. At this point, you should be able to generate an airspeed, generate an altitude, change a rate of climb, change a rate of acceleration, and be able to perform a simple leak check. There are a couple of other functions that I would like to show you. The first one is the jog up or down function. When you are at 2,800 feet here and you would like to check at what altitude a pressure switch goes off, let's say that it goes off at 2,810 feet, you will push on the blue box here, just like you would to change your altitude. But instead of inputting a new value like 2,801 and then click enter and go, and then 2,802 and then click enter and go, which would be very cumbersome, you can use the up and down arrow right here. When you do that, the altitude will increment foot by foot. As you can see here, 3, 4, 5, 6, and you will see the altitude increasing right there as well. This is very useful when you want to know at exactly what pressure your pressure switch goes off. It is also useful when you're doing an analog altimeter instruments and you do not know exactly where the needle is located, and you would like to increase your altitude a little bit so the needle is right on the dot, and at that point the altitude that you incremented would be the difference between the test set and the aircraft under test. Another thing that I find quite useful on this test set, there is a function that allows me to stop the test wherever it is, and that's the halt function right here. By clicking this button, all of the check will be stopped wherever it can and wait for me to resume the generation whenever I want. This is especially useful if you feel like you've made a mistake and you're not sure where you're going and you want to gather your thoughts, or if you have an emergency and you need to go away for a few minutes away from the aircraft. You can pause your check right here, and when you're ready to resume, you can just click go, and the test will resume and go back, continue going where you would like it to go. In this case, we're going back to ground. Okay, couple more information here. If you want to enter large altitude, you're going to click on the blue box, and instead of entering, let's say you want to go to 20,000 feet, instead of entering 2,0,0,0, which can become confusing if you have a lot of inputs to make, you might put one extra zero or miss 1 0 and not go to the altitude you want it to go to. What you can do is clear, input 2, 0, and then 000 here. That will allow you to put 20,000 feet all at once and save you a lot of button punching, which can create errors eventually. On the generation part, there's one last thing I would like to show you, is when you want to go to negative altitude, as part of the FAR 91.411 test, there is a negative altitude of 1,000 feet to generate. You will push here, and instead of entering the minus first that is located here, you will enter the value first, 1,000, and then click the plus minus sign that will enter minus 1,000 feet. You will click then enter and go, and the tester will go to minus 1,000 feet.